question of whether line isolation monitors or LIM are required in operating rooms or ORs, particularly in older versus newer rooms within a hospital setting, is addressed by referencing NFPA 99. It is important to clarify that there isn't a specific NFPA standard mandating the use of line isolation monitors. The NFPA 99-2002 document provides guidance on this matter. Section 10.3.3.11 addresses equipment grounding conductor monitoring. It states that all single-phase, 120-volt, 15 or 20 ampere circuits supplying life support equipment, isolated power systems, and receptacle outlets provided for connection of patient care equipment must have equipment grounding conductor monitoring devices. There is an exception to this requirement. The exception states that where recording, therapeutic, and diagnostic equipment are served from the critical branch, which is detailed in Section 10.3.3.22, an equipment grounding conductor monitoring device should also be provided in the critical branch. This exception could potentially be applied to newer operating rooms, as these rooms are often supplied from a critical or isolated branch. However, there is a separate requirement for ground fault circuit interrupters or GFCIs in operating rooms. NFPA 99 addresses this in Section 10.3.2.23 concerning GFCI receptacle outlets. This section states that receptacle outlets, equipment receptacle outlets, and equipment grounding conductor monitoring equipment must be provided with line isolation monitoring equipment and connected to outlets protected by GFCIs. This implies that every receptacle outlet in an operating room that is connected to a GFCI is required to be protected by a LIM. Given these guidelines, removing the LIM from the older operating room would not be justified, especially if those rooms have GFCIs installed. Similarly, if the newer operating rooms are provided with GFCIs, then LIM would be required in those rooms as well. In essence, the presence of GFCIs in an operating room triggers the requirement for LIM to provide an additional layer of electrical safety. It is essential to adhere to these standards to ensure the safety of both patients and medical personnel within the hospital environment. The requirements for electrical safety in healthcare facilities, particularly operating rooms, are outlined in NFPA 99, which focuses on Healthcare Facilities Code. The specific section related to electrical systems is Chapter 10. This chapter provides details on essential electrical systems, power sources, distribution, and the use of isolated power systems. The standards are designed to minimize the risk of electrical shock and ensure a continuous power supply for critical equipment. Firstly, NFPA 99 outlines the requirements for essential electrical systems or EES, which are crucial for maintaining power to critical areas during a power outage. These systems include the Life Safety Branch, Critical Branch, and Equipment Branch. The Life Safety Branch supplies power for illumination, alarm systems, and other functions essential for the safety of patients and staff. The Critical Branch provides power to specific areas and functions vital for patient care, such as certain medical equipment and selected lighting. The Equipment Branch serves equipment loads that, if stopped, would not pose an immediate threat to life or safety. Secondly, isolated power systems are a key aspect of electrical safety in operating rooms and other critical care areas. These systems are designed to prevent electrical shock hazards by isolating the electrical supply from ground. A line isolation monitor or LIM is used to continuously monitor the impedance from the isolated circuit to ground. If a fault occurs, the LIM alarms alerting staff to the potential hazard. Thirdly, NFPA 99 mandates the use of ground fault circuit interrupters or GFCIs in specific locations within healthcare facilities, particularly in wet locations and areas where patients are likely to come into contact with electrical equipment. GFCIs are designed to quickly interrupt power if a ground fault is detected, preventing electrical shock. These devices are especially important in areas where electrical equipment is used near water or where patients are connected to medical devices. Fourthly, equipotential grounding is addressed in NFPA 99 to minimize voltage differences between conductive surfaces and patient care areas. This involves bonding together all exposed conductive surfaces, such as medical equipment, metal piping, and grounded outlets, to create a common ground potential. By reducing the potential for voltage differences, the risk of electrical shock is minimized. Fifthly, regular testing and maintenance of electrical systems are essential to ensure their continued reliability and safety. NFPA 99 requires periodic testing of essential electrical systems, isolated power systems, and GFCIs to verify their proper operation. Maintenance activities should include inspecting and cleaning electrical equipment, testing batteries in emergency power systems, and calibrating monitoring devices. Sixthly, NFPA 99 includes specific requirements for wiring and grounding in patient care areas. These requirements address the type of wiring methods permitted, the separation of power and communication cables, and the proper grounding of electrical equipment. The goal is to minimize electrical noise and interference and to provide a safe electrical environment for patients and staff. Seventhly, risk assessments are an important part of ensuring electrical safety in healthcare facilities. NFPA 99 encourages healthcare organizations to conduct risk assessments to identify potential electrical hazards and to implement appropriate safeguards. These assessments should consider factors such as the age and condition of electrical equipment, the types of medical procedures performed, and the patient population served. Eighthly, NFPA 99 addresses the use of portable electrical equipment in healthcare facilities. Portable equipment must be inspected regularly to ensure it is in safe operating condition. Damaged or defective equipment should be removed from service immediately. Healthcare facilities should also implement policies and procedures for the use of extension cords and power strips to prevent overloading circuits and creating fire hazards. Ninthly, healthcare facilities should develop and implement electrical safety training programs for staff. These programs should cover topics such as basic electrical safety principles, the proper use of electrical equipment, and emergency procedures in the event of an electrical incident. Training should be provided to all staff members who work with or around electrical equipment, including nurses, technicians, and maintenance personnel. Tenthly, NFPA 99 is updated periodically to reflect changes in technology, clinical practice, and regulatory requirements. Healthcare facilities should stay informed about the latest edition of NFPA 99 and should update their electrical safety practices accordingly. This may involve upgrading electrical equipment, revising policies and procedures, and providing additional training to staff. In summary, NFPA 99 provides a comprehensive set of requirements for electrical safety in healthcare facilities. By adhering to these standards, healthcare organizations can minimize the risk of electrical shock, ensure continuous power supply for critical equipment, and provide a safe environment for patients and staff. It's important to note that the presence of GFCIs in OS generally necessitates the use of LIM. Therefore, simply removing LIM from older OS would not be justified if GFCIs are installed. Likewise, if the newer OS are equipped with GFCIs, LIM would also be required. These measures collectively contribute to a higher standard of electrical safety in critical care environments. The specific application of these standards can vary based on the exact configuration of the electrical systems in the OS. The requirement for periodic testing of essential electrical systems ensures that these systems remain reliable and functional over time. Testing includes checking the operation of automatic transfer switches, generators, and other components of the ES. The frequency of testing depends on the type of equipment and the criticality of the load it serves. NFPA 99 provides guidance on the appropriate testing intervals and procedures. Regular maintenance is essential for maintaining the reliability and safety of electrical systems in healthcare facilities. Maintenance activities include inspecting and cleaning electrical equipment, tightening connections, and replacing worn or damaged components. A preventative maintenance program should be established to identify and address potential problems before they lead to equipment failures or safety hazards. Proper grounding is critical for minimizing the risk of electrical shock and ensuring the proper operation of electrical equipment. NFPA 99 specifies the requirements for grounding electrical systems in healthcare facilities, including the use of grounding conductors, bonding jumpers, and ground fault protection devices. The grounding system should be designed to provide a low impedance path for fault currents, allowing protective devices to quickly clear faults and prevent electrical shock. The use of isolated power systems in operating rooms and other critical care areas is designed to prevent electrical shock hazards by isolating the electrical supply from ground. These systems typically include an isolation transformer, a line isolation monitor or LIM, and other components designed to limit the flow of fault current to ground. The LIM continuously monitors the impedance from the isolated circuit to ground and provides an alarm if a fault occurs. Ground fault circuit interrupters or GFCIs are required in specific locations within healthcare facilities to protect against electrical shock. GFCIs are designed to quickly interrupt power if a ground fault is detected, preventing current from flowing through a person's body. These devices are particularly important in wet locations, such as bathrooms and kitchens, and in areas where patients are likely to come into contact with electrical equipment. Electrical safety training programs are essential for ensuring that healthcare staff members are aware of the hazards associated with electricity and know how to use electrical equipment safely. These programs should cover topics such as basic electrical safety principles, the proper use of electrical equipment, and emergency procedures in the event of an electrical incident. Training should be provided to all staff members who work with or around electrical equipment, including nurses, technicians, and maintenance personnel. The risk assessment process involves identifying potential electrical hazards, evaluating the likelihood and severity of those hazards, and implementing appropriate safeguards to mitigate the risks. Risk assessment should be conducted regularly and should be updated whenever there are changes in the facility equipment or procedures. Portable electrical equipment, such as medical devices and power tools, can pose a significant electrical hazard if not properly maintained and used. NFPA 99 includes requirements for the inspection, testing, and maintenance of portable electrical equipment. Healthcare facilities should also implement policies and procedures for the use of extension cords and power strips to prevent overloading circuits and creating fire hazards. The equipment grounding conductor monitoring ensures that the grounding conductor is intact and providing a low impedance path for fault currents. This monitoring is particularly important in areas where patients are likely to come into contact with electrical equipment. The equipment grounding conductor monitoring device will provide an alarm if the grounding conductor is compromised. Receptacle outlets play a critical role in delivering power to electrical equipment in healthcare facilities. NFPA 99 specifies the requirements for the installation and wiring of receptacle outlets, including the use of tamper-resistant receptacles in pediatric areas and the proper grounding of receptacles in patient care areas. Regular inspections of receptacle outlets should be conducted to identify and address any potential hazards, such as loose connections or damaged receptacles. NFPA 99 is updated periodically to reflect changes in technology, clinical practice, and regulatory requirements. Healthcare facilities should stay informed about the latest edition of NFPA 99 and should update their electrical safety practices accordingly. This may involve upgrading electrical equipment, revising policies and procedures, and providing additional training to staff. Maintaining a safe electrical environment in healthcare facilities requires a comprehensive approach that includes adherence to NFPA 99, regular testing and maintenance, proper grounding, the use of isolated power systems and GFCIs, and ongoing training and risk assessment. By implementing these measures, healthcare organizations can minimize the risk of electrical shock and ensure a continuous power supply for critical equipment.